Okay, we are going to look at how to solve a radical equation with radical signs on both sides of the equal sign. Again, so just a little housekeeping rule. It's good habit to have. As you can see, just keep all your equal signs on a straight column here. So you will know exactly what's on one side of the equal sign, what's on the right-hand side. So you can keep track of things. In the event you make a mistake, you can come back and fix it a lot faster. And otherwise, people get lost. They will never find out what actually went wrong. Okay, so it's good habit. It saves you time actually in the long run. All right. So if you have radical signs like square roots showing up on both sides of the equal sign here, what you want to do is you want to keep, again, uh, the same spirit as we showed you earlier. You had just one square root. You want to isolate one of the square roots by itself, and preferably with a little more complex one. You don't want to bring that -2 over here. That will a little bit complicated, and this is a better setup. You want to put the simple square root x with something else. Okay, this is a good setup. And so what are we doing here? We try to solve for x, which means we want to isolate, we want to x all by itself. So the obstacle is that we have square roots on x. So how are we going to get rid of it? So we're going to undo the square roots. We simply just square them. Okay, so we square on both sides. That's a one key strategy in how to deal with radical equations is that if you have a square root, you square it. What happens if you have a cube root here? You want to cube it. Okay, we're not going to get into um, perfect cubes today, but you get the hint as how to get rid of the radical sign. Square roots, square it. So, okay, so let's do that. And I have a separate video on how to carry out FOIL on perfect squares involving binomials of square root x. I have a separate video. I'll put information there. You can go check it out for yourself. And so perfect squared, square root x minus 2 times square root x minus 2. And just FOIL first, outside, inside, last. In my video, I said you can go quickly, use the template, and go from there to this step directly. Save you a lot of time and housekeeping. You will go a lot faster. Okay. So left-hand side, square root x minus 2 squared is x minus 4 square root x plus 4. Square of a square root is just its inside called radicand. So x minus 8. Okay, so what have we accomplished? We had two square roots to begin with. After we square both sides, we have reduced, uh, simplified it into having just one single square root here. So from what we have learned previously and going forward is that we want to isolate this square root x. Okay, let's get to it. So this 4 should not be hanging around next to the square root x. We subtract 4 on both sides. Also, this x term should not be hanging around on the left-hand side either. So we want to subtract x on both sides. So once you carry this out, left-hand side should just be -4 square root x. And on the right-hand side, -8 minus -4 is -12. X minus x, the x disappears. So that looks pretty encouraging. Now we have -4 square root of x is equal to -12. We can further isolate the square root of x a little bit more by undo the multiplication. -4 is multiplied to square root of x. Undo the multiplication by division. So we divided by -4 on both sides, and we got to an even simpler radical equation, square root x equal to 3. Hopefully by this time, everybody knows what we have to do is isolate x, get rid of the square root of x, just simply square it on both sides. And once we accomplish that, we know x is equal to 9. And a lot of times you get a clean number like that, the chances are you got a good answer. If you get a messy term, then um, somewhere things have gone awry. Okay, so just like all the radical equations, we need to check for extraneous roots. Sometimes what you got will not work out. So let's check it out. How do we do that? We just plug this 9 for x into its original equation. The original equation was square root of x minus 2 equal to square root of x minus 8. So we substitute the 9 for x. So we got this. Square root of 9 is 3. 3 minus 2 is 1. Good. Right hand side of square root 9 minus 8 is square root of 1, which is also 1. So 1 will always equal to 1. So it looks like we have got ourselves a winner. The x equal to 9, we can accept that as a sound solution to our problem. Okay, so we will do more example and to reinforce the process as to why we do what we do at each step. Okay, we'll do a very similar problem. And as you can see, next problem, we have a square root on one side minus a number, and we have a even more complex square root on the other side. And radical equations, to get rid of the square roots, we square them. So square both sides, but equal treatment. If you do some operation to one side of the equal sign, you better do the other side as well. Again, keep all the equal signs on a single column will help you keep track of things. And it's a wise habits to adapt if you have not already start using that. And it's a good habit to have. So again, so that's a perfect square. So let's skip those steps. We can go directly to the third step. So that's a plus b squared is going to be a squared plus 2ab plus b squared. So a is square root of x, b is -5, a squared is square root of x squared is x. The middle part, 2ab, what does that mean? It's just 2 times a, then times b. So it's -10 square root of x. And again, I put a link for another video I did show us exactly how to take care of those perfect squares involving square root of x. Okay, so and the right-hand side, square root of x minus 7, you square it, it's just turned into x minus 7. Square and square roots sort of undid each other. Okay, so good. We went from complex looking square roots on both sides. After we square both sides, carry on a perfect square, we get down to this step. However, it still has a square root of x. What are we going to do? Remember, if you have a square root radical part, you want to isolate that part. Okay. Plus 25 has to go. Undo the plus, minus 25 on both sides. 25 is gone from the left-hand side. -7, -25 combined, you get -32. You still have this x. That needs to go. How do we do that? Find its opposite. When you have the opposites added together, they cancel out. So subtract x on both sides. Then left-hand side, you have negative 10 square root of x equal to negative 32. Undo the multiplication here by div division. So divided by negative 10 on both sides. You got square root of x is equal to 3.2. It's should looking good. So square both sides again, and you will have x equal to 10.24. Okay, last stop, check for strenuous roots. We plug in 10.24 into the original equation for x. However, for this time, we got the left-hand side is negative 1.8, and the right-hand side is positive 1.8. We know this can't be true because a negative 1.8 will never equal to positive 1.8. So this x equal to 10.24 has to be rejected because it does not work out in this original equation. So if you're using a online math program to do this problem at the last stop, you have to put in your answers for this one. Since when you check the solution, it gets rejected, the correct solution for this problem should be no solution. Don't put the 10.24 in there if the check for strenuous roots part rejects that uh, a potential answer. So just put in no solution. Okay, so those are the steps how to solve uh, a radical equations having square root signs showing up on both sides. I wish you success in solving these equations. Now you know all the ropes and strategies on how to handle them.